Hello data scientist, welcome to Skillcate. In this video, we shall build a credit scoring model for a bank, enabling them to make data-driven lending decisions. We shall use Logistic Regression classifier to build our model and Decile Methodology to formulate a lending strategy for the bank. For those of you who don't know us, we are Skillcate, and we are on a mission to bring you application-based machine learning education. We launch new machine learning projects every month, so make sure to subscribe to our channel to get access to all of our free ML projects. Alright then, let's get started. This is our problem-solving framework. We shall go step by step through this to understand, solutionize, and deliver on our project in hand. So let's start with understanding a business problem that we would solve in this credit scoring project. All of us would have come across this term credit scoring. It is basically a statistical analysis performed by banks and financial institutions to determine a borrower's credit score. Borrower's repayment history, length of credit history, number of credit inquiries made in the past, and number of active credit cards and loans all contribute to computation of a statistical 3-digit number called credit score. This number acts as a proxy for banks to gauge creditworthiness of any loan applicant. In simple words, banks use this number to make their lending decisions. Sounds simple, right? Actually, it is not that simple. There are multiple factors that make this decision problem complex for a bank. 1. Not all borrowers would have significant credit history to have a good credit score, or in fact, any credit score. 2. How big or small the bank is. A borrower having a good credit score might not visit a small lender, making the small lender's decisioning process not so straightforward. Let's understand this further. Based on the scale of operation, banks and financial institutions are placed differently on the risk spectrum and have different business strategies, as we can see here. A public bank that comes to the left of this spectrum would always want to minimize their business risk by considering only high credit score loan applicants for lending. A private bank would want to maximize their profit, which requires them to identify their optimal credit score tolerances. We will discuss this optimization part further while solving our business case. A new entrant that comes to the right of this risk spectrum, however, would have no other choice but to consider every applicant that comes to their door, be it the one having low credit score or the one having no credit score at all. Thus, every business on this risk spectrum would have a unique approach to assess loan applications and make lending decisions based on their business strategy. Now let's get to the credit scoring business case we have in hand here. So our client is ABC Bank Limited. They intend to build an in-house risk model to make data-driven lending decisions for subprime mortgages. By the way, subprime mortgage is a type of loan granted to individuals with poor credit scores. Business wants to maximize their profits with an eye on market expansion as well. We also have details on profit business books on a good loan and loss incurred on a bad loan, which is $100 and $500 respectively. Our client has also shared historical customer data with us that has details on borrowers' credit bureau records captured at the time of loan application and final outcomes on these loans, which is loan turned good or bad. Vaguely, this is how our dataset is structured. Let's talk about our dataset now. There are 30 variables in our dataset and around 3,000 observations. We also have descriptions on these 30 variables here. Let's go through them now. Variable target here is our dependent variable, which is a binary one and has zeros for good loans and ones for bad loans. So this is the variable we want our credit scoring model to predict. Anyways, next up we have these independent variables captured by the credit bureau at the time of these historic loan application filings. Here this Customer ID towards the end is a unique identifier for every borrower in this dataset and would not have any impact on loan turning good or bad. So we would not include this variable in our analysis. For all these highlighted ones, you may go through these in the next slide to understand what these financial terms mean. Alright, now when we understand the case, let's understand how we would go about solving it with a machine learning approach with this next section on solutioning intuition. At a high level, our solution architecture is something like this. Using 80% of our labeled dataset of historic loan applications, we would train a logistic regression risk model. And then we would use this machine learning model to predict the likelihood of loan repayments for the remaining 20% applications. Towards the end, we would use Decile methodology to identify the business rules for accepting or rejecting any new loan application, targeting business profitability as well as market penetration. At Skillcate, our endeavor is to take you through the end-to-end journey of solving real business problems, of which coding is just one part. So even if you have little to no experience of coding, don't worry. As part of this free course, we are giving you a free do-it-yourself toolkit having ready-to-use Python code for your hands-on learning and reuse. Let me introduce you to our Skillcate do-it-yourself toolkit now. This is your free Skillcate do-it-yourself toolkit that entails training dataset and Python source code. Link to access these files is in the description part below. Let me quickly take you through the structure of this toolkit now. This first file here is our dataset. The second file is the source code for building our credit scoring model. Let's open it now to get started on our model building journey. We are using Google Colab for model building, which is Google's free cloud platform for Python coding. Alright, now we are in Google Colab. As you may see here, I have segregated our code cells into various sections, which are given easy to understand names. Let's go section by section now to understand what our code does. I'll run the code parallelly as we speak so that you would be able to see the output as well. First section is on importing libraries and functions. Let's run it. Next up, we are importing our dataset from Google Drive. For this, you may first need to mount Google Drive like this. Authenticate on your Google account following these steps. Alright, we are done. Then we run this next cell for importing our dataset from Google Drive. Alright, that's done as well. Next up, we need to do a bit of data preparation in this third section. Let's start off by exploring our dataset. Shape function here returns the count of rows and columns we have in our dataset. As you can see, there are 3000 rows and 30 columns that we have. Next up, we have this head function which would show us the first few rows of our dataset. First column here is our target variable. Then we have customer ID as our column 2. And then we have our 28 independent variables. As we discussed previously, we would drop customer ID from our analysis. Let's do this using this drop function in this next cell. Now we may validate the revised count of columns using the shape function again. As you can see, columns have reduced to 29 now. Next up, we check for missing values using this isNA and sum functions, which returns a count of NA or not available fields for all variables. As you may see, we do have missing values in our dataset. We would fill these missing values using fill NA function with the mean value of each variable. This is a standard data science practice. Post this, we will check for missing values one more time just to be sure everything is well. We see all zeros this time, so we are good to go. Then we have these optional code cells for further data exploration. You may try these out yourself. Moving on, in this next section, we are splitting our dataset into 80% training and 20% test. Thus, we would have 80% of 3000, which is 2400 observations going into training the model, and the rest 20%, which is 600, going into testing model performance. All right, we are done. Next up, we shall do data normalization. This is again a standard data science practice where we scale all our independent variables. You can read more on data normalization using the link provided in the description part of this video. All right, we are done with this. Great. Now we come to the model building part. We are using Logistic Regression as our classifier here. Let's do this. Okay, our model is now ready. Congratulations to you for making it till this point. In this next section, we would analyze our model performance and results. This first cell gives us the confusion matrix. Over here, we can check how efficient our model is in classifying good loans as good and bad loans as bad. Moving on, accuracy score gives us the percentage of correct classifications. Higher this accuracy value, better the model. We already have over 80% accuracy score, which means we have a good model. In this last section, we are capturing probabilities for our predicted Ys using predict proba function. As you may see, it returns an array. First column here provides the probability corresponding to target equal to 0, which is probability of a loan being good. And column 2 gives probability of a loan being bad and is nothing but 1 minus the first probability. Great. Now in this next cell, we are writing our output file back to Google Drive, which should have model probabilities along with predicted Ys and actual Ys. Using the head function, we can have a look at this output file as well over here. So this is how our output file looks like. This file will get stored in our Google Drive folder, and we shall be discussing it in detail now. And yes, coding ends here. So we are back to our Skillcate toolkit folder. Over here, this C1 is the output file from our code. This C2 is the analysis file we have built using C1, and we'll go through this in a moment. And this last file is the client solution delivery presentation. Let's look at this C2 analysis file now to prepare a data-driven lending strategy for our client. This first worksheet here in this file is taken directly from the C1 file that our model sort of gave us. There are 600 observations over here. As you may recall, we split our dataset into 80% training and 20% test. So 20% of 3000 is 600 observations, and that's exactly what we have here. Moving on to columns, we have 5 columns in this file. First one is the serial number starting from 0 thanks to Python indexing. Next up, we have actual Ys from our test set. Here zeros mean historical loans that turned out to be good, and ones mean historical loans that turned out to be bad. Column C and D are model predicted probabilities for good loan and bad loans. As you know by now, their sum is always 100%. This column E is model predicted Y. Logistic regression classifier considers 50% as the default probability for making predicted Y as 0 and 1. Thus, as you may observe, predicted Y is 1 for probability of good less than 50% and is 0 when probability of good is over 50%. This predicted Y would not help us much because we do not want to keep the probability threshold at 50%. Rather, we want to find a custom threshold value for our client basis their business needs. Now, let's start making sense out of this data. Let's start off by sorting our data in descending probability of good loans. With this, now we have these loans sequenced in descending order of their loan repayment likelihood. So definitely as a bank, I would want to approve loans of these initial few customers. But the question is, where do I stop? To figure this out, we need to aggregate our dataset first using a statistical technique called Decile. Using Decile, we would divide this data already sequenced in descending order of probability of good into 10 equal parts. Let's do it. So essentially I'll put 1 against the first 60 observations here because we have a total of 600. And then you may use this simple formula. Alright, we are good. I've already done it in the next worksheet. On this data now, we need to insert a pivot table. We already have that as well in the next sheet. By the way, this analysis file is already present with you as part of your Skillcate DIY toolkit. You may keep it open as we speak for your ready reference. Now let's go through this table in detail. Here we have 10 deciles in these 10 rows. Against this we have count of observations in each decile, which is 60 for all sets. And then we have sum of actual outcomes. As you may know, the actual outcome is 0 for a good loan and 1 for a bad loan. So the summation of actual outcome essentially gives us the count of bad loans. Quite naturally, for initial few decile sets, as the probability of good is almost approaching 100%, actual wise would mostly be 0, so there are no bad loans. And as we go down the decile set, we have more bad loans. Column D here is interesting. It has minimum of probability good for each decile set. So for decile 1, if we look at our data, we have minimum of probability good as 97.15%, as you may see. Right, so similar way we have cutoff probabilities for all the remaining deciles as well. Great. Next up we have count of good loans, which is nothing but column B minus column C. Cumulative good and cumulative bad have accumulation of column E and column C respectively. You may go through their formulas. Then these columns H and I have percentages of these cumulative good bad values. And then we have a percentage of cumulative bad avoided at each level, which is 1 minus column I basically. Now, how do we read these columns that we have on our screen? Let's take this decile 1 for an example. For decile 1, practically speaking, we have our best customers here. And if a business wants to be extremely conservative with their loan approvals, they may take decile 1 cutoff probability as their approval probability threshold for loans. This way, business is funding loans for 12% of total good customers that come to them and avoiding 99% of bad customers that are coming to them. As we go down the decile, business is getting more good customers but at the cost of getting exposure to more and more bad customers. By the way, in statistics, cumulative good percentage is nothing but model sensitivity, and percentage of cumulative bad avoided is called specificity. When these two are plotted on a two-dimensional chart, we get an ROC curve. Area under this ROC curve gives us model performance, which we already know is over 80%. You may read more on ROC curve by following the link in the description part below. Alright, let's take stock of things now. We have been developing this risk model all this while for our client ABC Bank Limited. They wish to maximize their profits while keeping an eye on market expansion as part of their business strategy. We also know they incur a loss of $500 for each bad loan and book a $100 profit for each good loan. Using this information, we can compute profitability across our deciles like this. As we can see, at decile 6, business is maximizing on their profit. So this is the place our client ABC Limited would want to be if profitability is their only objective. The cutoff probability here is 85.47%, which means business may accept only those loan applications that have good loan probability more than this. However, as we are categorically told to keep an eye on market expansion as well, business may consider decile 7 as well, where they gain more market share at the cost of some of their potential profits. And the cutoff probability at this level reduces to 79.73%. As data scientists, our job is to give data-driven insights to business for making better decisions. So this is what we shall go back to our client with, wherein we give them both these options and allow them to make the final call. Now we are almost done with this credit scoring project that we had in hand. Let's discuss the client solution delivery presentation we would be making to them as part of closure of this project. Now let's look at the final delivery presentation we shall make to ABC Bank Limited on this credit scoring project. So our scope was to build a machine learning based in-house risk model, allowing business to make lending decisions for subprime mortgages. Based on our understanding of this assignment, we knew that ABC Bank Limited is placed towards the right of the risk spectrum, and their business objectives shall entail both profitability and market expansion. This is the high-level solution architecture that we have built. Next up, we tell them about assumptions we made while building this model, including missing values imputed with mean, and the fact that we use logistic regression as our classifier. And finally, as our deliverable, we tell them that we have built an in-house risk model that gives 83% accuracy, that is built with Google Colab's free online resources. And as our next deliverable, we give them these lending strategy options, wherein they may focus only on profitability or prioritize market expansion while compromising a bit on their profitability. Alright, this completes our credit scoring project. Hope you had fun all along. We post new machine learning project videos every month, so make sure to subscribe to our channel if you haven't till now. Good luck to you. Bye.